Mr. Williams.
Morning.
Are we ready to resume trial?
State's ready. Defense is ready.
Mr. Williams, are you ready for us to bring in the jury?
Yes, Your Honor.
Let's bring in the jury. Please be seated. Good morning. Happy Friday to you all. We made it. Giving you a little bit of a preview as to what I anticipate the day will look like. The state is going to continue with their presentation of the evidence. We are going to recess a little early today, about 3 o'clock. With that, we're going to give you all a lunch break, but it'll be a shorter lunch break just because we want to be able to recess at 3 o'clock. Is 30 to 45 minutes sufficient for that? Everyone has to be in unison. You're a jury now. All right. Thank you. State, please call your next witness.
The state calls Kelly Banky. Yes, I do.
Ma'am, once you're comfortably seated, pull the mic close to you, say your first and last name, and spell both names, please.
My name is Kelly Banky, Behnke.
How do you spell your first name?
Oh, sorry. First name's Kelly, Kelly.
Thank you. Do you wish to inquire?
I do.
You may proceed.
Thank you. Good morning.
Good morning.
So you've already introduced yourself. Where do you work?
I'm a senior forensic scientist at the Palm Beach County Sheriff's Office in the Forensic Biology Unit.
What does a senior forensic scientist do?
As a senior forensic scientist, my primary duty is casework, so I do both serology and DNA analysis on casework items of evidence. For serology, this includes detecting bodily fluids such as blood and semen, swabbing items of evidence for potential trace DNA. For DNA analysis, this includes doing the laboratory steps of the DNA process, as well as interpreting DNA profiles. I also write reports and I testify in court. Outside of casework, I can also participate in internal audits of the laboratory, do quality control checks of the different instrumentation of the laboratory, as well as I assist in training newer analysts.
Okay. So I was going to ask you what makes you a senior forensic scientist. Is that those extra duties that you just testified about?
It's also just experience. So I've reached the amount of experience needed to become a senior forensic scientist, and it gives me more of a leadership role in the laboratory, as well as I can, if the technical leader is out, I can serve as the technical leader of the laboratory.
How long have you been a forensic scientist?
I've been a forensic scientist for about 8 years.
What is your educational background that allows you to do this job?
I have a bachelor's degree in biochemistry from the University of Michigan and a master's degree in pharmacy with a concentration in forensic science, DNA, and serology from the University of Florida.
Have you received specialized training to do this job?
Yes, I went through extensive training at the Palm Beach County Sheriff's Office in both serology and DNA analysis. This included attending lectures and demonstrations on various tests or aspects of the laboratory. I also gave presentations about the theory behind the certain processes. During my training, I did tests on mock items of evidence, and then both trainings concluded in a competency exam, and this included a written portion, a practical bench portion, and a mock trial. Serology training was about 3 months, while DNA training was about 1.5 years.
Are you a member of any professional organizations?
Yes, I am. I'm a member of American Academy of Forensic Science, or AFS.
What does it mean for a crime lab to be accredited?
Accreditation means being recognized as meeting certain national and international standards for accurate and reliable testing.
And is the Palm Beach County Sheriff's Office Crime Lab accredited?
Yes, we are accredited by ANAB, or ANSI National Accreditation Board.
So approximately, how many items have you analyzed for either serology or DNA?
I've issued over 1,000 reports in either serology or DNA. For DNA, it's over 300 reports, and serology was over 600 reports. And each report might contain multiple samples.
Okay, so let's just get right to it. What is DNA?
DNA stands for deoxyribonucleic acid, and it's the genetic blueprint of all living things. You get half your DNA from your mom and half from your dad, and it's what makes you unique. Everyone has a unique DNA profile with the exception of identical twins.
Does each cell of the body have the same DNA pattern?
All nucleic cells have the same DNA profile, so DNA is found in the nucleus of cells. If you look at it like a fried egg, the DNA is contained in the yolk of the egg. And so the same profile is contained in all the nucleated cells, and so this DNA from your blood would be the same as DNA in your saliva.
Okay. How does somebody leave DNA behind?
There's many different ways someone can leave DNA behind. You can leave it behind possibly by touching something. You can leave it behind, say, if I cut my hand and I'm dripping blood on the floor, that's a way I could leave DNA behind.
If a person touches a surface, do they necessarily leave DNA behind?
Not necessarily. There are different factors. It's not an all-inclusive list, but there are many different factors that can contribute to leaving DNA behind. For example, if I come up and I touch this table once, I might not leave as much DNA behind as if I stand here and I touch it for an hour. Or sometimes in general, rougher surfaces, you'll leave more DNA behind than smoother surfaces. There's also people called shedders that they just naturally leave more DNA behind.
If a person's DNA is not present on a surface, does that definitively tell us that that person was not at or around that surface?
I can't determine what occurred at a surface or anything, so I can only analyze what my samples.
Okay. Can you explain the difference between detecting touch DNA, like what we've been talking about touching surfaces, and DNA from bodily fluids?
So in general, bodily fluids have a higher concentration of DNA than, say, a trace sample from touching something.
You mentioned serology. What is the difference between serology and DNA testing?
So serology is detecting and identifying bodily fluids such as blood and semen. This is usually the first step before it moves on for DNA analysis. So for example, if a shirt comes into the laboratory, maybe that shirt needs to be swabbed for possible trace DNA. Those swabs would then move forward for DNA analysis.
Okay. Do you, at the sheriff's office lab, do you always get an item like a shirt, or do you sometimes get actual swabs?
No, sometimes they come in as already swabs, so there are swabs that come in. For serology testing, it would then be preserved, meaning it's taken from its original packaging and put into coin envelopes where it's labeled with the case number, the submission number, a description of what it is, initials, and date.
Okay. Can you walk us through the steps of DNA analysis?
Yes, there's 4 laboratory steps in DNA analysis. The first step is called extraction, and it's used to break open the cells and release the DNA. Going back to the egg with the fried egg with the yolk, it's used to break open the cell and release the DNA from the yolk. And this is done by applying heat and chemicals. The second step is called quantification, and that's used to determine how much DNA is present in the sample and can tell stuff about the quality of the sample. The third step is called amplification, and it's used to make millions and millions of copies of specific areas of the DNA, kind of like a DNA Xerox machine. And then the fourth step is called separation and detection. It's used to separate the DNA based on size, and then it's captured by a camera, which then correlates into a computer file that then I can view at my desk.
Okay. Once you get through those 4 steps, do you compare what you get from the sample to something called a known standard?
Yes, so to do comparisons, I would need known samples. This is known to come from an individual or reference standards. For example, if it's 2 oral standards, that's normally taken by swabbing the inside of someone's mouth, and then the profile generated from those swabs would then correlate to that person. So then I can compare the known samples to the unknown profile where I don't know where it's possibly coming from.
Okay, so just to kind of give an example, if we have my known standard swabbed from my cheek, and then you have a shirt, you could compare my DNA sample to the swabs from the shirt.
Yes, I know that the swabs are coming from a shirt, but I don't know who's composing that sample, so I'd have to have some knowns to compare to that unknown profiles.
Okay. When you analyze evidence for DNA, do you necessarily have complete profiles or all the information that you need?
No, not necessarily. Sometimes we have low level or partial profiles where some of the genetic information is what's called dropping out. So it's not in the profile. You don't have a full profile. And that could just be because it was a low level sample to begin with. It could be something called degradation, which means that the DNA is broken down, sometimes by heat or humidity.
Is there a baseline amount of information you need on an unknown, like something like the shirt, to be able to compare it to a known standard?
Not necessarily. It's analyst discretion on if there's enough information to compare to from the unknown. So it's analyst discretion, but we want enough information in order for it to be more specific. For example, if you are going car shopping and you go into a dealership and you're just like, I need a car, I want a car. That's not very specific. They're going to direct you to a lot of different cars. However, if you say, I want a Honda Accord, 4-door, Bluetooth, blue exterior, that's going to direct you more to this specific car.
Okay. Is it possible for a piece of for DNA analysis? I'm going to start that over. Is it possible from a piece of evidence for there to be a mixture of more than one person's DNA?
Yes, we don't just analyze single source. We can analyze mixtures, and in my laboratory, we analyze up to 4 individuals.
How do you parse that out to know that there's more than one person or potential person, and who's who?
So after the 4 laboratory steps, the 5th step is called interpretation. And this is when I look at the profile generated, and I have to find out some information about this. Is this sample comparable? Is there enough information there for me to do comparisons to? I also have to determine number of contributors. So how many people are making up this sample? going back to my explanation of DNA, you get half your DNA from your mom and half from your dad. So at any location, there should be up to 2 pieces of information for one person, 1 piece from your mom and 1 piece from your dad. If I'm seeing throughout the profile that maybe there's 6 pieces of information at each location, that's indicating me maybe this is a mixture of 3 people. 2 pieces of information is from 1 person, 2 is from a second person, and 2 is from a third person. So the pieces of genetic information at each location can help me determine how many people are making up the profile. Another thing that I look at is something called imbalance. So ideally, if one person's contributing to this mixture, they would contribute each piece of information about equal. So the peak heights that I'm looking at, I kind of look at something similar to like an EKG with peaks through it, should be about equal from one person. If I have at one location something that's 5,000, is called RFUs, relative fluorescent units, so peak height, and then one that's 100, those might not be pairing together. Maybe that's a mixture of 2 people. One's contributing one and one's contributing the other.
Okay. And do you look for consistency throughout the sample at the same height, I guess, of your peak?
I look through the whole sample in order to determine number of contributors.
Okay. So I want to talk about kind of on a broader spectrum how you give this information when you're reporting the results. And then we'll talk about this case. What is it called, the way that you report your findings? Would you like me to ask that a different way?
Yeah, can you clarify that?
Sure. So when you've done all the steps and you are now reporting the result, do you report it in a specific way?
So I would report all my results from my findings.
Do you use what's called a likelihood ratio?
Yes, so after I determine number of contributors and determine if I can compare to the sample, if there's I then do my comparisons to my known profiles. And if there's something that I cannot visually exclude, I would run a statistic called a likelihood ratio. A likelihood ratio is a statistical calculation used to assess the probability of the evidence given 2 alternate explanations of the data. So, and the higher the likelihood ratio, the more support for one explanation over the other. For example, if you walk home and there is a perfect cake waiting for you at home, and you want to recreate this cake, one explanation of the data might be you added flour and eggs. Another explanation might be you added flour and vinegar. So you're giving weight to one explanation over the other of how do you compose this cake.
Okay. And where do those likelihood ratios come from? Like the statistics? Is there a database? Like how does it work that you are able to get those kind of statistics?
So there is a database that we use for allele frequencies, so pieces of genetic information. How likely are we to see those in the general public? So each piece of information has what's called an allele frequency, how likely it is to see it in the public. Okay. We also use a program called StarMix, which is a validated software program used for interpretation, and that's what we use to run our statistic.
Okay. So let's talk about this case and kind of see some of these concepts in action. So I want to take you back to November of 2021. Did you receive items of evidence for both serology and DNA testing in this case?
Yes, I did.
Okay, so I want to go through a list, and I'm just going to say an item, and we'll talk about whether you had it. But before we get there, did you do just 1 round of testing in this case?
No, I did 3 rounds of testing in this case.
How does that happen that you do testing in multiple rounds? Do you just keep testing the same items? Do you get new information? How does that work?
So we do have a case submission policy where you won't necessarily test all the items at once for that first round of testing. It's to help triage the samples. So you might do some round items during round 1 and then you'll continue into a second round of analysis. Also, other items might come in and you might have to do another round of testing.
Okay, so could it be that the same items continuously get tested against new known standards as the case progresses?
They won't continuously get tested, but I will, if a new standard comes in and I already processed some unknowns, I would then compare that standard to all the previously done unknowns.
Okay. So let's go back to November of 2021 and we'll go through that list.
May I refer to my case file?
If that
you
would
need
refresh, I was going to ask the court if that would refresh your recollection.
If it refreshes your recollection, you can look at your report, but look at your report and then turn it over and then answer whatever question.
Okay, thank you.
Okay. Did you receive a black hooded sweatshirt for DNA testing and serology?
Yes, I received a black hooded sweatshirt. Went through the DNA process.
Okay. And did you receive socks?
Those were also sent through the DNA process. Yes.
Okay. What about 2 swabs from a plastic headpiece of headphones?
Yes, those were also received for processing.
Okay. 2 swabs from ear cushions, circle attachments of headphones?
Yes, those were also received.
2 swabs from ear cushions, interior of headphones?
Yes, those were also received.
2 swabs from red stain labeled C, bar across bike?
Yes, that was received for testing.
2 swabs from handlebar of bicycle?
Yes, those were received.
2 swabs from seat bottom side of bicycle?
Yes.
2 oral standards from Ryan Rogers?
Yes.
2 oral standards from Cynthia Rogers?
Yes.
2 oral standards from Justin Rogers?
Yes.
And 2 oral standards from Brian Rogers?
Yes.
Okay. So when we say oral standards, is that known sample that we're talking about?
Yes, those are the known samples.
Okay. So for all of the known samples, do you run those through the DNA? Did you run all of those through the DNA process to get a profile so you could then compare it to the evidence?
I didn't run all these standards through the DNA process originally, but yes, they would essentially go through the DNA process as well to generate a profile. But for this first round of testing, I processed the oral standards from Ryan Rogers and the oral standards from Justin Rogers.
Okay. The other standards, did those come into play in some of the other rounds of testing?
Yes, those were completed during the third round of testing.
Okay. So I want to talk, let's just go through it and we'll go through each item that you analyze. I want to start with the black hooded sweatshirt. Before we get there, let's back up a little bit. I read through a list and I went through a list of items that you received for testing. How do you decide how to label those items when you're reporting your findings?
So the serologist would label them based off of either what they see or what the packaging says. So if it comes in as 2 swabs from red t-shirt, the serologist would then label it as 2 swabs from red t-shirts. Or if it's an actual item of evidence, they'll still label it based off the packaging, such as a black hoodie.
Okay, so in this situation, we have black hooded sweatshirt. Was that actual item received by the lab?
Yes, the actual item was received by the laboratory. I didn't process or swab this item of evidence, but that was received by the laboratory, and then I moved it on for DNA analysis.
Okay. So the different areas of the black hooded sweatshirt that were tested for DNA, were those areas identified by the person who did the serology?
Yes, the actual areas that were swabbed were done by the serologist.
Okay, and you're following that labeling?
Yes.
Okay. So let's talk about the different areas of the black hooded sweatshirt, starting with the outside cuffs. Did you do DNA analysis on that area?
Yes, on the outside of the cuffs.
Okay. And what does it mean when I ask you how many contributors you found to the DNA profile? What does that mean?
So number of contributors is how many people I determine are making up this mixture. And that's based off those things I talked about earlier with the peak heights and the number pieces of genetic information. I use that information or determine how many people are making up this sample.
Okay, so if it is one profile making up the sample, what's that called?
It can be called like a single source, or number of contributors is one.
Okay, so for the outside cuffs of the black hooded sweatshirt, how many contributors did you have?
I had number of contributors was one for outside cuffs.
Okay, and what was your result when you compared that to, or did you compare that to the known standards that you had?
Yes.
And what was your result?
For the outside of the cuffs, I assumed that Ryan Rogers was present and a statistical calculation may be provided upon request, and then I excluded Justin Rogers.
Okay, so let's talk about what that means. Let's start with assuming a contributor. What does that mean?
So assuming a contributor is for intimate samples, so say it's a swabs from my hand. It's known that it's coming from my hand, I can assume to be present. So it's based off the sample type and the actual profile. If I cannot visually exclude myself and it's coming from my hand, I can assume to be present in that sample.
Okay, so did you have information when you're doing this kind of DNA analysis to make those assumptions?
Yes, the items were submitted through our DNA request system, and they'll say potentially who the item belongs to. So for the black hoodie, it was known to belong to Ryan Rogers, so I assumed him present on those samples.
Okay. Do you also visually look at it to make sure you can't exclude?
Yes, I won't just assume him if he's not. I cannot visually, if I can exclude him in that profile. So he has to be visually present in that profile as well before I can assume him in that profile.
Okay, and then you said that Justin Rogers was excluded.
Yes.
What does that mean?
That means when I did my comparisons to the profile generated, there were inconsistencies. They were not consistent, so I excluded him.
Okay, so let's talk about the outside, bottom, front, and back of the black hooded sweatshirt. Did you run DNA analysis on this particular sample?
Yes, I did.
And how many contributors did you have to that sample?
I determined that number of contributors was 2 people.
Okay, and what were your results for those 2 contributors?
So Ryan Rogers was assumed to be present in the DNA profile obtained, and a statistical calculation can be provided upon request.
Same as the last one?
Same as the last sample, yes. And then for the second contributor, I determined due to excessive dropout of genetic information, that portion of the mixture was determined to be unsuitable for comparison.
Okay, so you can't say anything about the second contributor.
I could do no comparisons. So before I do any comparisons, I have to make sure it's suitable for comparisons, meaning that there's enough information there for me to compare to. I determined that that portion of the mixture was unsuitable for comparison, so no one would be compared to that portion of the sample.
Okay, were you able to exclude anybody?
Yes, I excluded Justin Rogers.
Okay, and before we go any farther, in this first round of testing, did you have a known standard for Semmie Williams?
No, I did not.
Okay. So continuing with the black hooded sweatshirt, the outside, back, and underarms. Did you do DNA testing on that area?
Yes, I did.
And what were your results?
So I determined the number of contributors to be 2 people. I again assumed Ryan Rogers in this mixture, and I excluded Justin Rogers from this mixture.
Okay.
Also, additional comparisons may be made upon submission of a standard. So I could compare to that contributor too. There's more I could compare to if a standard was submitted.
Okay. So different than the outside, bottom, front, and back where there was too much dropout, you actually had enough information if you had a standard?
Yes.
Okay. So I want to move on to the socks, starting with what was labeled sock 1.
Okay.
Did you do DNA testing on sock 1?
Yes, I did. For that sample, I determined that the number of contributors was 4 people. I again assumed Ryan Rogers in this, so a statistical calculation could be made upon request. And then I excluded Justin Rogers from this sample. I also, additional comparisons may be made upon submission of a standard.
Okay, so you had enough information, you just needed additional standards if anybody wanted that information.
Yes, I could do additional comparisons to that sample.
Okay. And what about sock number 2?
Yes, so sock number 2, I determined number contributors to be 4 people.
Okay. And what were your results?
Is it okay if I read from my report for the statistic?
Any objection, defense? No. You can do.
Okay. So for this sample, I again assumed Ryan Rogers, but I could not visually exclude Justin Rogers from the sample. So there was 2 explanations of the data. Explanation 1, the DNA profile obtained originated from Ryan Rogers, Justin Rogers, and 2 unknown unrelated individuals, versus explanation 2, the DNA profile obtained originated from Ryan Rogers and 3 unknown unrelated individuals. So the likelihood ratio generated, the DNA profile obtained is approximately 4e to the 6, or 4 with 6 zeros after it, times more likely if it originated from Ryan Rogers, Justin Rogers, and 2 unknown unrelated individuals, than if the DNA profile obtained originated from Ryan Rogers and 3 unknown unrelated individuals.
Okay. So is that likelihood ratio you were talking about with the cake?
Yes, so it's giving very strong support for explanation 1 versus explanation 2.
Okay. And when you said 4E6 or 4 with 6 zeros, that would be
4 million.
4 million. Okay. So 4 million times more likely the first scenario, Ryan Rogers, Justin Rogers, and 2 unknown unrelated.
If it originated from Ryan Rogers, Justin Rogers, and 2 unknown unrelated individuals, than if it originated from Ryan Rogers and 3 unknown unrelated individuals.
Okay. So let's move on to the swabs from the plastic headpiece of the headphones.
Okay.
What did you find? What were your results for this?
So for the plastic piece you were asking about?
Yes. And does the sheriff's office have a labeling process where you actually give each item or each swab a submission number?
Yes, so the items come as submission numbers as well.
Okay, so I'll refer to the submission number 2 so we can stay organized on your reporting.
Okay.
So submission 8, swabs from plastic headpiece of headphones.
Yes, so for that sample, I determined number contributors to be 1 person. I excluded both Ryan Rogers and Justin Rogers, and additional comparisons may be made upon submission of a standard.
Okay.
I also determined that the source was a male DNA profile was obtained.
Okay, so how do you do that?
Determine the male?
Yes.
So some of our markers are used as a sex determining marker. So it can determine if there's a possible, if there's a female present or a male present.
Okay. So let's move on to submission 9, swabs from ear cushions, circle attachments of headphones. What were your results, or did you run DNA testing on this?
Yes, I did.
And what were your results?
So for submission 9, I determined number contributors to be 2 individuals. I could not visually exclude Ryan Rogers from the sample, so I ran a likelihood ratio. So the 2 explanations of the data, the DNA profile obtained originated from Ryan Rogers and an unknown unrelated individual, and explanation 2, the DNA profile obtained originated from 2 unknown unrelated individuals. And then I'm going to read off the likelihood ratio. The DNA profile obtained is approximately 1e to the 29th, or 1 with 29 zeros after it, times more likely, or very strong support, if it originated from Ryan Rogers and an unknown unrelated individual, than if the DNA profile obtained originated from 2 unknown unrelated individuals.
Okay. What's that? Do you have that number? 1 with 29 zeros after it?
Yes, it's 100 octillion.
So 100 octillion times more likely that it's Ryan Rogers and an unknown individual than if it's 2 unknown individuals.
If the DNA profile obtained originated from Ryan Rogers and one unknown unrelated individual, than if the DNA profile obtained originated from 2 unknown unrelated individuals.
Did you exclude anybody?
Yes, I excluded Justin Rogers.
Okay. So let's talk about submission 10, swabs from ear cushions, interior of headphones.
Okay.
How many contributors did you find for this submission?
So for this submission, I determined number of contributors to be 2 individuals.
Okay, so let's talk about your results. What were your results for this?
So I could not visually exclude Justin Rogers from the sample, so I ran a likelihood ratio. The first explanation of the data, the DNA profile obtained originated from Justin Rogers and an unknown unrelated individual. And explanation 2, the DNA profile obtained originated from 2 unknown unrelated individuals. The DNA...
I was just about to ask what the statistic was. You're ahead of me.
You're good. The DNA profile obtained is approximately 112 times more likely or moderate support if it originated from Justin Rogers and an unknown unrelated individual than if the DNA profile obtained originated from 2 unknown unrelated individuals.
Okay, so this is the first time we've heard moderate support. Is that something are those words, strong versus moderate, do those come from that statistic, whatever that number is?
So we use something called a verbal scale, which is used to translate into words the likelihood ratio numbers. So anything above 1e to the 6 or 1 million is very strong support. And then there's also strong support, moderate support, limited support, or uninformative. So if you consider, so it's just to translate that number into words.
Okay. So was that for contributor 1?
Yes, that he was associated by our software with contributor 1.
Okay. And were you able to come up with any other results for the swabs from the ear cushions, interior of headphones?
Yes, so for each of these samples, I did the comparisons to both Justin Rogers and Ryan Rogers. I could not visually exclude Ryan Rogers from the sample, and so I ran a statistic. The 2 explanations, the DNA profile obtained originated from Ryan Rogers and an unknown unrelated individual, and the second explanation, the DNA profile obtained originated from 2 unknown unrelated individuals. The DNA profile obtained is approximately 3e to the 8th or 300 million times more likely or very strong support if it originated from Ryan Rogers and an unknown unrelated individual than if it originated from 2 unknown unrelated individuals.
Okay, so this one fell under very strong support.
Yes.
Okay. Did you run any other statistics for this particular sample?
Yes, I also ran the 2 standards together. So under this data assumptions, our star mix does not support both Ryan Rogers and Justin Rogers together to be contributors to this mixture. So the 2 explanations that I ran for that likelihood ratio was the DNA profile obtained originating from Ryan Rogers and Justin Rogers, and the DNA profile obtained originating from 2 unknown unrelated individuals. And it determined it was unable to generate a likelihood ratio. The likelihood ratio was 0. It was they were unable to be in this mixture together given the data.
Okay, so how does it work when you're dealing with siblings?
So siblings share more DNA because they're related. You're getting half your DNA from your mom and half from your dad, and they share the same parents. They're more likely to share more DNA, pieces of genetic information in their DNA profile because your mom might give the same piece of information to both siblings, or your dad might also be giving the same piece of information to both siblings. You might inherit different pieces of information. Oh, absolutely, sorry. Your parents, you could be inheriting either the same piece of information from your parents, or you could be inheriting 2 different pieces of information from your parents.
Okay. So is that a reason we could see siblings in this scenario?
So it's possible that since siblings are sharing more information, I could not visually exclude either of them from it. That's also why I wanted to run them together to show that both of them together cannot be in this mixture.
So let's move on to submission 11, swabs from red stain labeled C, bar across bike. Did you, before we get to the DNA testing, did you also do serology on this sample?
For submission 11?
Yes.
Yes, I did blood testing for this sample.
Okay. And what do you do to test for blood?
So for blood testing, I perform both a presumptive and a confirmatory test for blood. The presumptive test is used to indicate if a substance is possibly present. I'm not saying it's for sure present, but it's possibly present. Then if that is positive, it's followed by a confirmatory test, which is used to indicate with certainty that the substance is present. So for blood, I would take a small cutting of the swab, and then I would add my chemicals to it, and it's a color change test. So if the change is to a vibrant pink color pretty much immediately, it'd be positive for blood. This is then followed by the confirmatory test for blood. For the confirmatory test, I use a cartridge about 2 inches by 1 inch. I add a cutting of a sample to a solution and then add that to a cartridge. If 2 lines form in the cartridge, it indicates blood is present. If only 1 line forms, it indicates it's negative.
Okay. After doing these tests on submission 11, the swabs from the red stain labeled C bar across bike, were you able to determine whether or not it was blood?
Yes, it was positive for blood.
Okay. And when you did the DNA testing process, what were your results?
So for submission 11, the swabs from the red stain labeled C bar across bike, I determined number contributes to be 1 individual.
And were you able to compare your knowns to that?
Yes, so I could not visually exclude Ryan Rogers from the sample. So that was followed by a likelihood ratio. So the 2 explanations, the DNA profile obtained originating from Ryan Rogers, and then the second explanation, the DNA profile obtained originating from an unknown, unrelated individual. The DNA profile obtained is approximately 2e to the 29th or 200 octillion times more likely or very strong support if it originated from Ryan Rogers than if the DNA profile obtained originated from an unknown, unrelated individual.
And did you exclude anybody?
I excluded Justin Rogers from this sample.
Okay. Let's go to submission 14, swabs from handlebar of bicycle. Did you do DNA testing on this sample?
Yes, I did. I determined number of contributors to be 1 individual.
And what were your results?
For the sample, I could not visually exclude Ryan Rogers from the sample. So this was followed by the likelihood ratio. Explanation 1, the DNA profile obtained originating from Ryan Rogers. And explanation 2, the DNA profile obtained originating from an unknown, unrelated individual. The DNA profile obtained is approximately 2e to the 29th or 200 octillion times more likely or very strong support if it originated from Ryan Rogers than if the DNA profile obtained originated from an unknown, unrelated individual.
Okay. Let's move on to, well, did you exclude anybody? I'm sorry.
I excluded Justin Rogers from this sample.
Okay, let's go to submission 15, swabs from seat, bottom side of bicycle. Did you run DNA analysis on this sample?
Yes, I determined number contributors to be 1 individual.
And what were your results?
I could not visually exclude Ryan Rogers from this sample, and so this was then again followed by the likelihood ratio. Explanation 1, the DNA profile obtained originating from Ryan Rogers, and explanation 2, the DNA profile obtained originating from an unknown, unrelated individual. The DNA profile obtained is approximately 2e to the 29th or 200 octillion times more likely or very strong support if it originated from Ryan Rogers than if the DNA profile obtained originated from an unknown, unrelated individual.
And did you exclude anybody?
I excluded Justin Rogers.
Okay, so let's fast forward to your second round of testing. Just let me know when you're ready.
1 second.
You're fine.
Okay.
Okay, so in your second round of testing, were you working with a lot of the same items of evidence?
So another standard was submitted for second round testing. So in my report, there is comparisons done from that standard to everything that was previously done during the first round of testing.
Okay, did you also have an additional set of swabs? In addition to the new known standard, did you have an additional set of swabs from, as labeled from a different piece of evidence?
Yes, I had submission 26, 2 swabs from red stain from camo bandana.
Okay, and the known standard, the new known standard that you had, what was that labeled?
That was 2 oral standards from Semmie Williams Jr.
Okay, so let's talk about this round of testing. So starting with submission 1, black hooded sweatshirt, we'll just go right through. Outside cuffs. What were your results when you compared the new known standard to this sample?
I excluded Semmie Williams Jr. from that sample.
Okay. Going to outside bottom, front and back. What was your result for the outside bottom, front and back?
I excluded Semmie Williams Jr. from all comparable portions of that profile.
Okay, so let's talk about that. You said all comparable portions. What does that mean?
So for that area outside bottom, front, and back of the black hood sweatshirt, there was a portion of that mixture that I determined was unsuitable for comparison. I wouldn't do any comparisons to. So when I'm saying I'm excluding him from all comparable portions, I'm excluding him from the portion that I can compare to.
Okay, and you can't tell us anything about the portion you can't compare.
No, I wouldn't compare anyone to that portion of the sample.
Okay. And what about the outside back underarms of the black hooded sweatshirt?
So I excluded Semmie Williams Jr. from that sample.
Okay. So let's move on to SOC 1, submission 3A. What were your results?
I excluded Semmie Williams Jr. from that sample.
Okay. And what about SOC 2, submission 3B?
So for submission 3B, I could not visually exclude Semmie Williams Jr. from that sample, so I ran a likelihood ratio. Explanation 1, the DNA profile obtained originated from Ryan Rogers, Semmie Williams Jr., and 2 unknown unrelated individuals. And explanation 2, the DNA profile obtained originated from Ryan Rogers and 3 unknown unrelated individuals. The DNA profile obtained is approximately 625 times more likely or moderate support if it originated from Ryan Rogers and 3 unknown unrelated individuals than if the DNA profile obtained originated from Ryan Rogers, Semmie Williams Jr., and 2 unknown unrelated individuals.
Okay, so that one sounds a little bit different than what we've been hearing with it sounds kind of the reverse. Can you explain this statistic, how it's different than what we've heard previously?
So that number, so the likelihood ratio, the higher the likelihood ratio, the more support for one explanation over the other. For this one, it was giving more support for that second explanation of the data. It was giving moderate support for the second explanation over the first explanation of the data.
Okay, and the previous ones were giving more support to the first explanation versus the second.
Yeah, the ones I read from the previous report were more support for the first explanation.
Okay, so we're almost like inverted. I'm sorry, we're almost like inverted.
Yes, so it's giving more support for the second explanation over the first explanation.
Okay, so let's talk about submission 8, swabs from plastic headpiece of headphones. What were your results for this item of evidence?
So I could not visually exclude Semmie Williams Jr. from the sample, so I ran a likelihood ratio. The 2 explanations of the data, the DNA profile obtained originated from Semmie Williams Jr., and the second explanation, the DNA profile obtained originated from an unknown, unrelated individual. The DNA profile obtained is approximately 2e to the 22 or 20 sextillion times more likely or very strong support if it originated from Semmie Williams Jr. than if the DNA profile obtained originated from an unknown, unrelated individual.
Okay, and we already talked a little bit about this piece of evidence when we talked about the first round of testing, but how many contributors did you visually see on this piece of evidence?
So I determined for that sample there was 1 contributor.
Okay, let's go to submission 9, swabs from ear cushions, circle attachments of headphones. What were your results for this?
So for that sample, I could not visually exclude Semmie Williams Jr. from it, so I ran a statistic. The 2 explanations of the data, the DNA profile obtained originated from Semmie Williams Jr. and an unknown unrelated individual. And explanation 2, the DNA profile obtained originated from 2 unknown unrelated individuals. The DNA profile obtained is approximately 295,220 times more likely or strong support if it originated from Semmie Williams Jr. and an unknown unrelated individual than if the DNA profile obtained originated from 2 unknown unrelated individuals.
Let's talk about submission 10, swabs from ear cushions, interior of headphones. What were your results for this item of evidence?
So for that sample, I again could not visually exclude Semmie Williams Jr. from it, so I ran a likelihood ratio. The two explanations of the data, the DNA profile obtained originated from Semmie Williams Jr. and an unknown unrelated individual. And explanation 2, the DNA profile obtained originated from two unknown unrelated individuals. The DNA profile obtained is approximately 6,193 times more likely or moderate support if it originated from two unknown unrelated individuals than if the DNA profile obtained originated from Semmie Williams Jr. and an unknown unrelated individual.
Let's talk about submission 11, swabs from red stain labeled C bar across bike. What were your results?
I excluded Semmie Williams Jr. from that sample.
Submission 14, swabs from handlebar of bicycle. What were your results?
I excluded Semmie Williams Jr. from that sample.
Okay. And submission 15, swabs from seat bottom side of bicycle. What were your results?
I excluded Semmie Williams Jr. from that sample.
Okay, so let's talk about the swabs from the red stain of the camo bandana. I want to start with serology. Did you do serology on these swabs?
Yes, I did blood testing on those swabs.
And followed that same procedure you already told us about?
Yes, so I did the presumptive test for blood followed by the confirmatory test for blood.
Okay, and what were the results?
Immunological confirmatory test for blood was positive.
Okay, so after you did the serology, did you go forward with DNA testing on this sample?
Yes.
Okay, and let's talk about your results for this sample. How many contributors were there?
I determined that for the sample, number of contributors was 2 individuals.
Okay, and let's talk about your results.
So for this sample, I could not visually exclude Ryan Rogers from the sample, so I ran a statistic. The first explanation, the DNA profile obtained originated from Ryan Rogers and an unknown unrelated individual. And the second explanation, the DNA profile obtained originated from 2 unknown unrelated individuals. The DNA profile obtained is approximately 1e to the 29th or 100 octillion times more likely if it originated from Ryan Rogers and an unknown unrelated individual than if the DNA profile obtained originated from 2 unknown unrelated individuals.
Okay. Were you able to compare Semmie Williams' known standard to this sample?
Yes, I also compared his standard to the sample, and I could not visually exclude him from the sample. So I ran a likelihood ratio. Explanation 1, the DNA profile obtained originated from Semmie Williams Jr. and an unknown unrelated individual. And explanation 2, the DNA profile obtained originated from 2 unknown unrelated individuals. The DNA profile obtained is approximately 2e to the 7th or 20 million times more likely or very strong support if it originated from Semmie Williams and an unknown unrelated individual than if the DNA profile obtained originated from 2 unknown unrelated individuals.
Okay. Now, I want to stay on this sample for just a moment. Are you able to parse out, is probably not the scientific word that you would use, but I'm hoping that we're talking about the same thing. Contributor 1 versus contributor 2, which one's which? Like who's contributing more to the profile is I guess what I'm asking.
So when I ran it through StarMix, which is our interpretation software, I first did what's called a deconvolution, which is used to separate a sample into its component parts, kind of like a coin sorter. So it's going to say this information goes to contributor 1, and this information is possibly going to contributor 2. For that, mixture proportions, contributor 1 was contributing 98% of the mixture, and contributor 2 was contributing 2% of the mixture.
Okay. And when you did your statistics and you said you couldn't visually exclude Ryan Rogers, were you talking about contributor 1 or contributor 2?
I could not visually exclude him from contributor 1, but when I run it through StarMix, it's not to contributor 1. It's going to be looking at the whole profile when it for the likelihood ratio.
Okay, and then when you visually couldn't exclude Semmie Williams, were you looking at contributor 1 or contributor 2?
I could not visually exclude him from when I run the likelihood ratio. It will look at both contributors when running the likelihood ratio.
Okay, and when we're talking about bodily fluids versus touch DNA, which do you expect, based on your background, knowledge, training, and experience, to leave more DNA?
In general, bodily fluids have a higher trace samples would, such as from touching something, from.
Let's move on to your third round. Okay, so I want to talk about did you also have submission 29, fingernail clippings from Ryan Rogers?
Yes, so those were also processed.
And submission 30, 2 swabs from nose piece area of sunglasses?
Yes, those were processed.
Submission 31, 2 swabs of temple pieces of sunglasses?
Blair.
Additional comparison.